If I told you that right now you are moving faster than a fighter jet, would you believe me? Well, this is not an exaggeration. The earth beneath your feet is spinning over 1600 km per hour. At the same time, it is orbiting the sun at more than 100,000 km per hour. And the sun itself is racing around the center of Milky Way over 800,000 km per hour. In other words, you are traveling through the universe at incredible speed right now. So the question is, if we are moving that fast, why don't we feel anything? To understand this, let's take another example. Think about yourself traveling on a bus. When it suddenly starts moving, you get pushed back into your seat. And when it suddenly stops, you're thrown forward. But once it's going on a steady speed, you feel nothing. You can place your phone on the dashboard, a cup of coffee in the holder, and everything just sit there perfectly. So why do you feel the start and the stop, but not the journey in between? The answer to this question is one of the most important idea in all of the physics. That we actually don't feel speed, we feel change in speed. That is the reason why a bus is moving at constant speed, you can feel completely still. The moment the speed changes, that is, in the start and the stop of the journey, there is a change in speed and you feel it. But the real mystery is why we feel this change in motion. So, there is a universal rule that every object resists the change in its movement. If something is at rest, that is not moving, it wants to continue resting. And if something is moving at certain speed, it wants to keep moving at the same speed. So when a bus is moving and then suddenly brake, your body wants to keep move forward. It resists the stop. And the resistance to the change in motion is what you're feeling. Not the speed, not the motion, but the resistance to the change in motion. And this resistance is called inertia. So in simple terms, objects don't want to change. If they are at rest, they stay at rest. If they are moving, they keep moving at the same speed unless something interferes. And this simple idea becomes Newton's first law of motion. And that's exactly why we don't feel the earth movement. The earth is moving at incredible fast, but its motion is so smooth and constant. There is no sudden speed up or slowing down. So your body has nothing to detect. But here is where things get really strange. If you can't feel the speed, so if you are at rest or moving at constant speed, you can't tell the difference, right? Then how do we know whether we are moving or not? Are we really at rest or in motion? How do we tell? The answer to this eventually led to the one of the greatest discovery in history of physics. A discovery that changed the way we think about space and time. Thank you.